There's a classic joke in tech. There are only 10 types of people in the world. Those who understand binary and those who don't. The joke works because 10 in binary actually means 2. Whether you use computers every day or you write the code behind them, this video is for you. We'll look at how traditional computers run on ones and zeros, how binary works, and why both quantum computing and our own minds advance when we step beyond binary. And for the first time in this series, I'm trying a giveaway, a 64 gigabyte thumb drive. I'll tell you how you can enter to win later in the video. Hi, I'm Judy, and this is day 10 of my 90-day challenge to post something of value almost every day. I've worked in IT for 30 years, building systems based upon binary logic. What fascinates me is how you can see binary showing up in other places, such as our biology. Neurons, they fire or not. Genes, they switch on or off. Even energy medicine speaks of flow or blockage. Though nature isn't purely binary, and when it comes to reasoning and beliefs, binary thinking can actually trap us, choosing I can or I can't when there might be other options that include I'm learning, or I'm getting better. And speaking of which, I'm still learning how to edit videos, so this one took longer than I hoped, and a special thanks to my nephew, Tyler, who helped with taking care of honeybees while I was trying to get this edited and out the door. And thank you for watching, because it really does help knowing that there is someone on the other end of this, and it gives me some energy to keep going throughout the 90 days. And whether you're into learning binary or self-growth, the patterns I'm going to talk about today connect both. So let's start with a number system that you're already familiar with and use every day, and that is called base 10. And we're calling it base 10 because there's 10 possible digits, 0 through 9. If you take the number 4,298, the 8 is in the ones, the 9 is in the tens place, the 2 in the hundreds, and the 4 in the thousands. Each place is a power of 10. Ones is 10 to the power of 0, tens the 10 to the power of 1, hundreds 10 to the power of 2, and thousands 10 to the power of 3. So 4,298 is really 4,000 plus 200 plus 90 plus 8. In base 10, we have 10 digits, so we use powers of 10. Computers work in base 2. The building block of most computers today is the transistor. And you can think of a transistor as this little light switch. It can either be on or off. And if it's on, we consider that to be a 1. If it's off, we consider that to be a 0. And that's where binary comes in. Only 2 choices. We call the numbering system base 2 because there's only 2 possible digits, 0 or 1. 8 digits or bits make a byte. So if we want to convert from binary to decimal, instead of using the powers of 10, we use the powers of 2. And we only include where there is a 1. So in this case, 2 to the power of 1 gives us 2. So if the geek joke didn't make much sense at the beginning, I hope it's starting to make more sense now. You may have seen storage devices like this 16 gigabyte thumb drive. Notice its binary representation for 16, where the 1 is in the 2 to the 4 position. If you look at a 32, double the space, the 1 is shifted left by 1, which makes it 2 to the 5 or 32. The 64, the 1 is yet again shifted to the left, making it 2 to the 6 or 64 gigabyte. So here is your chance to win this exact thumb drive. It is a 64 gigabyte, so I will be giving you 64 billion transistors, probably more, because of how data is stored. They actually kind of put multiple together into a flip-flop. To win this, what you can do is put a comment down below to what the answer is. You know what, even if you don't get the right answer, I don't care. I'm just looking for increasing the comments. But the answer I'm looking for is, what does binary 1010 mean in decimal? Put that answer down below, or even if you want to post in something like you're thoroughly confused by this, or you appreciated certain things. I'm just looking for some interaction. I've been putting a lot of energy into these videos. I really do hope that you did get something from this. And what I just want to finish off with is, computers use this binary in terms of logic. If we go down that path in the next 90 days, we'll talk a bit more about programming. But things like, if this is true, then do this. Otherwise, do something different. And sometimes we might actually catch ourselves only stuck between those two choices. Is it true or is it false? When in actuality, there might be more choices involved. If we do pigeonhole ourselves into just two states, it can block off a lot. And so quantum computing is actually having more than two states. It's actually 0, 1, or both 0 and 1 simultaneously. So if you're interested in that, comment below and I'll expand on that. So I'm cutting this off. I love my family and they are a priority to me, and this has taken me so long to edit. I do hope that you got some value from this. And again, please like and subscribe wherever you're at, whether it's tech, whether it's philosophy. I just wish you the best and hope that you can join this discussion again. Best wishes to everyone.